Google DeepMind and Intrinsic joined forces with the UCL to create RoboBallet, an AI that takes robots to a whole new level. In Switzerland, a four-legged robot is smashing badminton rallies with humans. Australia is rolling out billion-dollar Ghost Shark AI submarines that could change naval warfare forever, and South Korea just launched a $1 trillion humanoid alliance to win the global robot race. This is wild, and it's only the beginning. So let's break it down. Start with the factory floor, because this is where scale happens. This AI powerhouse comes from a collaboration between UCL, Google DeepMind, and Intrinsic. The core tech combines reinforcement learning with graph neural networks, which basically means it can learn by doing, and fast. Instead of humans spending days or even weeks programming every single move to avoid collisions and optimize tasks, RoboBallet does it in seconds. It's been tested with 8 robotic arms, handling up to 40 tasks simultaneously, and still not missing a beat. What's wild is that it doesn't just memorize how to do one job. RoboBallet learns general rules for coordination, which means it can instantly adapt to new factory layouts or sudden changes. Let's say one robot malfunctions or an obstacle shows up out of nowhere. RoboBallet replans everything on the fly. We're talking hundreds of times faster than real time. It's not just planning where each arm goes, it's making sure they all work together like a well-rehearsed performance. This isn't just theory. The team open sourced RoboBallet, and it's already being tested for welding, pick and place, and painting. The foundation is solid, even if it can't yet handle every type of robot or obstacle. As DeepMind's Matthew Lai put it, RoboBallet makes robots move in harmony, not just to avoid crashes, but to work faster and safer together. Now that robots can move together like dancers, here's the twist. Some of them are actually learning to play sports. A quadruped robot called ANYmal just learned how to play badminton. Not badly either. It's good enough to keep up a 10-shot rally with a human opponent. This isn't a joke, it's a real research project out of ETH Zurich. Using reinforcement learning and a pretty advanced visual system, ANYmal is already known for navigating rough terrains and climbing rocks. But now it's on the badminton court, with a racket in its robotic arm and 2 cameras tracking the shuttlecock in real time. It's not just reacting, it's predicting where that thing's going to land, adjusting its stance, and swinging like a toddler with surprising coordination. The robot weighs about 50 kilograms, stands at half a meter, and balances like a champ, even when lunging sideways to return a shot. The challenge wasn't just hitting the shuttlecock, it was doing it while staying upright and moving fast. The team trained it in simulation, where it played thousands of virtual rallies to get the technique just right before ever touching a real racket. It's fascinating how the same tech that helps ANYmal stay steady on rocky terrain during industrial inspections is now helping it plan footwork and racket swings. And this isn't just a party trick, it opens up real questions about how legged robots can function in fast, unpredictable environments, not just in factories, but in sports, entertainment, maybe even rehabilitation. Still, at $150,000 per unit, this one won't be showing up at your local gym anytime soon. But for elite training centers or labs looking to push the boundaries of what quadrupeds can do, this is just the beginning. Meanwhile, beneath the ocean, things are getting even more intense. Australia just went all in on autonomous submarines. They're called Ghost Sharks. Extra large, AI-powered undersea drones, and the government is spending 1.7 billion Australian dollars to build dozens of them with a United States partner, Anduril Industries.
Ghost Shark complements it. Ghost Shark operates in conjunction with it. That's the point that I made up front. And it also works in conjunction with our surface fleet. And what is clear is that going forward, nations will need to have an autonomous underwater military capability, and that's what Ghost Shark represents. But we will also need very much a long-range capable submarine in the future, and I'm really confident that that's what we are developing under the banner of AUKUS by providing Australia with that capability.
These things are huge, extra large autonomous undersea vehicles that don't need a crew, don't need to surface, and can carry out surveillance or even strike missions deep into contested waters. What's wild is that Australia took this from concept to fleet-ready production in just 3 years. That's insanely fast for military tech. Nuclear subs take decades. Ghost Shark? It's hitting the water in January 2026. They're built for range, stealth, and intelligence. Capable of launching from ships or coastlines, they can perform long-duration patrols across millions of square kilometers. Anduril co-developed it with the Royal Australian Navy in a kind of experimental defense partnership where both sides took risks to get this into service fast. Now, a lot of the details are classified. We don't know the exact number or even the full capabilities. But what's clear is that these drones are part of a larger geopolitical shift. Australia is reacting directly to China's growing naval presence in its region. Ghost Shark offers coastal defense, domain awareness, and even the potential for deterrence without putting human lives on the line. And unlike the $368 billion nuclear subdeal under AUKUS, Ghost Shark is relatively affordable and already operational. The government even mentioned the possibility of exporting these to allies, so we're not just looking at a national defense tool. This could be the prototype for a new class of AI-powered naval dominance. Back on land, South Korea is playing a different kind of long game. Earlier this year, they launched the K-Humanoid Alliance. It's not just another robotics program, it's a full-scale, government-backed push to become a global leader in humanoid robots by 2030. Over 40 companies, universities, and research institutes are in this thing, including Samsung, LG, KAIST, and Rainbow Robotics. They've already pooled over $1 trillion, around $750 million for this initiative. Their plan? Build humanoid robots with world-beating specs. We're talking under 60 kilograms, over 50 joints, a payload capacity above 20 kilograms, and speeds over 2.5 meters per second. The alliance is split into two big focuses, hardware and AI. The AI team, led by Seoul National University, is working on a foundational model that can handle vision, hearing, motion planning, and real-time sensing. Think of it as the brain. Meanwhile, hardware teams like HD Hyundai and Doosan Robotics are handling the body, high-performance joints, sensors, and power system. And yes, they're also developing specialized solid-state batteries and custom AI chips to keep these bots running safely and efficiently. The entire structure of this initiative is built around industry, academia, government collaboration. South Korea doesn't just want humanoids, they want to set the standards for the next global wave of robotics, especially as the humanoid sector is expected to grow from 1.5 billion now to 38 billion by 2035. So the competition is heating up. China is racing forward. The United States has Figure, Tesla, Apptronic, and now South Korea wants to be right there, if not leading. But let's zoom out, way out, to Mars. There's a new conversation happening in space circles, and it's not about sending more humans, it's about replacing them. Scientists and engineers are seriously considering artificial astronauts, robots with human-like bodies and minds, on future missions to the moon, Mars, and beyond. One reason is simple: survival. Humans are fragile, expensive to support, and limited by biology. Robots don't need oxygen, food, or sleep. They don't suffer from radiation, and they don't get homesick. With reinforcement learning in AGI or even ASI further down the line, these androids could plan, adapt, and execute space missions better than humans ever could. NASA's already tested humanoid prototypes like Valkyrie and Robonaut, and Elon Musk has talked openly about sending Tesla's Optimus robot to Mars in 2026 ahead of the first human missions, not as cargo loaders, but as real explorers. Meanwhile, planetary scientists like Pascal Lee are envisioning even more advanced super astronauts. These would be androids with artificial superintelligence, capable of safeguarding human DNA on interstellar journeys. Not just tools, but full-on successors. As Lee puts it, we'll start seeing these machines not as products, but as our offspring, extensions of ourselves into the cosmos. That's it for now. If you want more humanoids, AI, and next-gen robotics, hit subscribe and stick around. Big stuff is coming.